Hey Pre-Calcers, welcome to another online lesson. This could be the shortest lesson as far as number of slides, as I only have two different ones here on rational equations and inequalities. Again, whenever you hear that word rational in math, of course we think about fractions. So all of these equations and inequalities we see in this lesson will be kind of fractiony. So our main goal when we have something like this, I think, is to knock out the denominators to make this a little bit easier to work with. And typically, because we've been working with them earlier this chapter, we'll be dealing with a lot of quadratic equations and factoring and the like. Well, when we knock out the denominator on this one, we want to multiply by something that would cancel out this x plus 4 and x minus 1, but then we have this weird trinomial here. But what often happens is, some of you have maybe recognized already, is that I can factor this trinomial, and sure enough, once you know, it factors into the denominators of my first two terms. So actually this will end up to be x plus 4 times x minus 1 is the factored form of this denominator. So what I'm going to multiply everything by then is that factored trinomial. If I multiply everything by x minus 4 times, x plus 4 times x minus 1, let's just see what happens. I'm having a hard time writing here today. Again, I put big brackets around all this stuff to show that I'm multiplying it by all that. Now when I multiply the first term by this, you should notice that the x plus 4's will cancel out. Remember, you can only cancel out things that are multiplied or divided. So in this case, the x plus 4's would cancel out, and what I have left with then is x times x minus 1. And then I'll do that same thing with my next term here. And notice in this case, what cancels out is the x minus 1's. So those will cancel out, and what I have left with then, and watch out for this, that minus sign, the 2 is still there. The x minus 1's have canceled out, so then I have x plus 4. And lastly, don't forget about multiplying also by this other term that's on the other side of the equal sign. I think you can see here that everything will cancel out. The x plus 4's as well as the x minus 1's will cancel out. And so what I have left here then is simply just 20. Alright, so now I've gotten rid of my denominators. This looks a little bit better. This is just kind of a weird algebraic expression that we just have to be careful about. But let's go to work on this. So I distribute my x here. I'll get x squared minus x. Be careful about the minus sign here. I think of this as negative 2, so negative 2x minus 8, like that. And then 20 is my answer over there. Now I'm just going to combine everything that I can here. The x squared, of course, I can't. Negative x and negative 2x is minus 3x minus 8 equals 20. When we have quadratics, as we may have gathered from earlier this chapter, we like to have everything equaling 0. So I'll subtract 20 from each side. I'll have x squared minus 3x minus 28 equals 0. And now I have a quadratic. I can solve this through any number of means, like graphing or the quadratic formula or completing the square. But I'm going to try factoring. That might be my most prudent effect here. So I have to factor this as x and x. Momentary interruption there, but I'm back at it here. And this is actually going to be minus 7 plus 4, like this. And when I set each of those equal to 0, I get x equal to 7 or x equaling negative 4, which looks like my answer, right? But here's the thing to watch out for. I'm going to put in here, but wait, those may not be my answers, and the reason is I better go back and make sure that neither of those answers make my denominator of my original equation equal to 0. And sure enough, you would see that this negative 4 here, if I put that back in the original one, it makes this denominator equal to 0, which is bad. So my actual answer then is I have to cross out this negative 4. That can't be an answer. And my only answer here is just x equals 7. So kind of an involved problem. Lots of steps from trying to knock out the denominators to solving an equation, again oftentimes a quadratic, and then not only is it tough enough, but then when you're done you got to make sure to check out your answers to see if it's alright. Alright, now we're going on to the next slide here. I'm just going to pause this for a second while I talk to this student who is knocking at my door. Alright, here we go back again, everybody. And we're going on to the very next one. And look at this bugger. So this is an inequality, obviously, and it's rational because it's kind of fractiony. And this looks like a bear, certainly. How do we go about attacking something like this? Well, we could do this algebraically, perhaps, but I think your best bet is to go ahead and graph this on your graphing calculator. And not so much, you can look at the graph of it, perhaps. We are looking for when the y values here are greater than 0. So I think the best bet for a problem like this is to draw a number line like this and take a look at the factored form of what we have up here, and I'm going to put in the opposite.
That flu shots are available by the nurse's office until 8:15 this morning.
There we go, there's a flu shot announcement for all of you guys interested in that. So I'm going to put in some values here that would make all these factored parts equal to 0. Those are going to be kind of some critical points that I'm going to examine here. So it looks like my furthest one to the left would be negative 2. If I put negative 2, of course, in here, that would make it equal to 0. And then I am going to have a negative 1. And probably also good to check 0, even though that's not one of those features there, but check right around there. And then also 1, and it looks like also 3. So what I'm going to do is I'm going to graph this, or I'm going to enter this on my graphing calculator. I'm going to set my table up so I can take a look at these x values and the corresponding y values. So if I do that, and we'll be practicing on one of these in class as well. So if I look at this table here, and I'm sorry I don't have a shot of that, but I don't have my calculator on my computer yet anymore. But if you look at your table here, when I look at negative 1 and values less than negative 1, my values on the calculator are negative. The y values anyway. Okay? And then when I look between negative 2 and negative 1, it looks like they're positive. I set my table up just going up by 0.5 so I can clearly see a value in between these anyway. And then between negative 1 and 0, it looks to be positive again, the value I have. Okay, and then between 0 and 1, it's also positive. Alright, so far so good. Then between 1 and 3, though, it turns back to be negative. And then when I am greater than 3, it is also positive. Now, how does that help me in this problem? Well, keep in mind I'm interested in when is this greater than 0. So I can tell by my signages on this graph here that sure enough that's the areas that I want to be my solutions. So my solutions then for this particular problem would be when x is between, notice I have to use just a strictly less than or greater than sign because that's how the original was, negative 2 and negative 1. Also between negative 1 and 1. Now I don't have to take a break there at 0 because 0 is okay. It's not going to make the whole function go undefined like negative 1 or positive 1 would. And then the next region where it is positive is when x is greater than 3. So rather than an algebraic approach to solve this problem, this is more of looking at a table of values and trying to put in the regions where this inequality is true, in other words, when it's greater than 0. Anyway, the best thing to do is to practice on these problems, which we will when we get back to class, but that gives you a little bit background on these fairly tough rational equations and inequalities. Alright, we'll see you guys in class.